In this video, we gonna talk about the Taylor and Maclaurin series. This one is also about power series. You have the function fx represented as the power series n equal to 0 to infinity of Cn x minus a to the n, and you see that this one is going to be the center at a. Okay, so it's gonna the a here will be your center. Okay, and it is in terms of c0 plus c1 x minus a c2 x minus a squared and so on. The thing that we like to find is going to be, we like to find the coefficient c0, c1, c2. So you have, okay, so you have C0, C1, C2, C3, and so on. So we like to find the formula for C0, C1, C2, and C3. So we're gonna begin by differentiating both sides, okay? So we have f prime x is gonna give you C1. Okay, so it's going to give you C1 dominate here, and it's going to be 2C2, 2C3, and C4 respectively. Okay, and you have F double prime X. This one will give you 2C2 plus other term. Okay, and F triple prime will be 2 times 3C3. Okay, and you have the n derivative is gonna turn out to be n factorial cn, which is the constant, and you're gonna have other term in terms of x minus a. So you see that the thing that you're gonna look for is gonna be the constant term. For fx is gonna be c0. F prime x is going to be C1, will be constant term. For F double prime x is going to be 2C2 for the constant term. And for the third derivative, it's going to be 2 times 3C3. So basically, it's going to be just differentiate, and you'll be able to get rid of, like, you're going to see that this one going to be on this guy, and this guy is going to be on this guy. Okay, so this is how we find f prime, f double prime, f triple prime, the constant term. Okay, and you have the n derivative. The constant term turn out to be n prime cn, and you're gonna have the sum of the term with x minus a factor. So from here, this will lead to the formula for C2, C1, C2, C0, C1, C2, C3, and Cn respectively by plugging in x equal to a. So you see that when you plug in x equal to a both sides, so you're gonna get a minus a minus a square, a minus a to the third, and a minus a is 0. So this one will be disappear, disappear, disappear. So the thing that will survive when you plug in x equal to a will be fa equal to c0. Okay, so this one is the yellow one that we have. And you have f prime a equal to c1. Okay, so it's going to be your c1, and f double prime a will be c2, so it's going to be 2 fact c2, and f triple prime a is going to be 3 factorial c3, and you have the n factorial cn. Okay, so this will allow you to find Cn by just divide both sides by n factorial. So you see here that you have Cn equal to the n derivative of f at a over n factorial for n greater than or equal to 0. Okay, so you have a formula for Cn. Let me box this guy a little bit. So it's gonna be this is the formula for Cn, and it's gonna be plugged in to the formula here. So you have your Cn, okay, given by this formula, and this one you're gonna plug with f to the na over n factorial. So this one will be just this term, okay, and this one will give you the representation in terms of power series. Okay, so you see that we have successfully find the formula, this guy, okay, and this guy is called Taylor series. Okay, so this guy is called the Taylor series of f at a. Okay, and when a equal to 0, the formula will be reduced in terms of f0, x minus 0, x minus 0 square, x minus 0 to the third. So when you have the power series with the center at a equal to 0, this guy is gonna have a special name called the Macrine Theory. They both English. Okay, so this one is English and this guy is also English. Okay, so let's try to find Taylor series for the fx equal to e to the x at a equal to 0. So for this one, okay, so you're gonna have to find f0. Okay, so you will need f0, f prime 0, f double prime 0, and so on. So you will need the n derivative at 0. Okay, so you will need the n derivative at 0. So we begin by just differentiate one time. So you have f prime x, this will be e to the x, okay? And you have f double prime x, this guy will be also e to the x, okay? This function exponential not gonna change when you find derivative, and you have the n derivative stay exactly the same, so it's gonna be e to the x. So when you plug in x equal to 0, the thing that you would get is gonna be just 1, 1, 1, and 1, okay? E to the 0 equal to 1, okay? So in this case, you have, they are they kind of consistently the same number, okay? And you're gonna have e to the x will be just the formula series n equal to 0 to infinity of the n derivative at 0 over n factorial x to the n. Okay, so this is the formula for Taylor series at a equal to 0. And you're gonna just plug in, so it's gonna be series n equal to 0 to infinity, and you have the n derivative equal to 1, and you're gonna get 1 over n factorial, and you have x to the n, okay? And this one will be Taylor series. Okay, so this one will be Taylor series, and this will be the Taylor series for e to the x. The question also asks you about the radius of conversion. Okay, so the question asks you about the radius of conversion. The thing that you can recall is going to be, hey, it look like something that we have done before. So it's going to be x to the n over n factorial. And we have this one in 11.8. In 11.8, we have the first example that you have x to the n over n factorial. Okay, example 30, number 2. Okay, so you see that the radius of convergence turn out to be equal to infinity in that case. So we're gonna just answer, okay, by example 30, number 2, the radius of convergence is equal to infinity. What does it mean to have the radius of conversion equal to infinity? It means that this formula will be valid for any real number x, and we're gonna just write x in R. Okay, so it means that you don't have to worry about plugging in. You can plugging in any x, and this formula will be valid, or the series turn out to be conversion for every value of x. Okay, so that is going to be the radius of convergence is equal to infinity. The next one, you have fx equal to 1 over x to the third, and you like to find the power series or the Taylor series for this guy when the center is at a equal to 1. So you have fx equal to 1 over x to the third. So this one is going to be just x to the negative 3 first, right? And then you're gonna have to find the first derivative, second derivative, until the nth derivative. Okay, so this is what you like to find, and you're gonna plug in x equal to a. Okay, let me recall you the formula a little bit, okay, for gaining some understand. So this guy, you have a, and the formula is turned out to be 3n equal to 0 to infinity of the n derivative at 1 over n factorial, and you have x minus 1 to the n. Okay, so our purpose is gonna be, we're gonna aim for the n derivative at 1. Okay, so we're gonna aim for the n derivative at 1. So you're gonna find the first derivative, second derivative. Okay, let me use this space. So it's gonna be f prime x. Okay, f prime x is gonna be negative 3x to the negative 4. Okay, so it's gonna be negative 3x to the negative 4. The second derivative will be negative 3, negative 4, x to the negative 5. Okay, and the third derivative is going to be negative 3, negative 4, negative 5, x to the negative 6. So you can guess, okay, for the n formula. So you see that 4 turn out to negative 4 turn out to be negative. Okay, so you see that this one is the index equal to 1. Okay, so this is 1, 2, 3. And what is number 4? The number 4 here turned out to be 1 plus 3. Okay, so you see that this one is going to be negative of 1 plus 3. So you have to like notice this one on your own. So this one is negative 1 plus 3. This one is negative 2 plus 3. This one is negative 3 plus 3, and so on. So you may guess that if you have the nth derivative, this would be what? This would be, you see that it's going to be 3 terms. So it's going to be negative 3, negative 4, negative 5, and you continue. Okay. So you continue this one, and you're gonna have what is called, it's gonna be somewhere that we're gonna stop, right? And we're gonna have x to the negative n plus 3. Okay, so let me write it in red for you to understand. So you see that the power that we just have, it should be n to the negative n plus 3. Okay, so this one. And you see that, hey, how about, what is this guy? What is this guy? It is negative 5, and this guy is negative 6. So they're kind of consecutive. right? So they kind of consecutive or next to each other. So if this one is negative n plus 3, the thing that you can do is going to be, would this guy be negative n plus 4? Sorry, plus 2. Okay, it should be like a one step, okay, one step smaller. So in this case, it's going to be negative n plus 2 instead, okay? And it is correct actually. So that is going to be that guy. And how many terms do we have here? So you see that this one, you look for one term. This one is two term corresponding to second derivative. This one is three term correspond to the third derivative. So here it's going to be n derivative. So it's going to be n terms. Okay, so let me also mention this one is going to be n term. Okay, so it's going to be n term. So if you would want to simplify this one, you can just move -1 from each parenthesis. So -1, -1, -1, -1 is going to come from each parenthesis. So it would lead you to -1 to the n. And you're going to have 3 times 4 times 5, okay, up until n plus 2. Okay, so it's going to be this number. And you notice that, okay, let me complete this one first, -n plus 3, okay? And you see that, hey, this is almost look like factorial, okay? So this is almost look like factorial. However, it's gonna be -1 to the n. So if I like to write this one in terms of factorial, I would have to add 1 and 2. So if I add 1 times 2 and I'm going to divide by 1 times 2, and I just copy every other term down. Okay, so I just copy every other term down. Okay, so it's gonna be like this. Okay, so you see the green guy, I just insert 1 times 2. Okay, so I just insert 1 times 2 into this one, and everything turned out to be fine, right? And you can write this one as 1 times 2 times until n plus 2. So this one would lead you to n plus 2 factorial. Okay, so this one would lead you to n plus 2 factorial. And you have -1 to the n. You have n plus 2 factorial over 2. Okay, so this one is the orange guy, okay, and you have x to the negative n plus 3, okay, so that one will be fnx, and you're gonna put x equal to 1 for all of this one, okay, so you're gonna have, okay, so you're gonna just see that this can turn out to be fnx, and so you would have the n derivative at 1, okay, so it's the n derivative at 1 turn out to be -1 to the n, okay, so it's -1 to the n plus 2 factorial over 2, okay, so it's going to be over 2, and you're gonna just have x equal to 1, okay, so you get this one, right? So that's it, right? So that's it, and this one will be just the thing that we gonna plug into the formula. You see, we have the blue guy already. Okay, so we have the blue guy that we're gonna plug in. So this equal to, okay, sum n equal to 0 to infinity, and you're gonna plug into the formula -1 to the n, n plus 2 factorial over 2 over n factorial, and you have x minus 1 to the n. Okay, so let me move this one a little bit. I need some space. Okay, and you have x minus 1 to the n. Okay, so it's gonna be that guy. And so this one will give you series n equal to 0 to infinity of -1 to the n, and you have over 2, and you have n plus 2 factorial over n factorial, x minus 1 to the n. Okay, so we have to work on this red term. Okay, so I'm going to highlight this one. Okay, I'm going to work on this term. What is this term? N plus 2 factorial over n factorial. So we recall that n plus 2 factorial. Let me drop my calculation here. N plus 2 factorial. This one is 1 times 2 times until you times n plus 1 times n plus 2, and the final term is equal to n plus 2. And okay, so let me, I have to move this guy close to this a little bit, and you're gonna have n plus 2, and you're gonna divide by n factorial. Okay, so you're gonna divide by n factorial, and n factorial is 1 times 2 times until n. So you're gonna just get rid of these two guys, and the thing that you have left turn out to be the yellow guy. Okay, so I'm gonna copy the yellow guy up there. So it's gonna be series n equal to 0 to infinity. Okay, so you have -1 to the n over 2 times the yellow guy, which is n plus 1, n plus 2, and you have x minus 1 to the n. Okay, so that will be just this term. Okay, so it's going to be to the n. Okay, so this one will be just the power series that we looking for. Okay, and if you want to find the radius of conversion, okay, so if you want to find the radius of conversion, you just use the technique that we have studied in the previous clip. Okay, so for the radius of convergence, I will ask you to do this one on your own, and I'm gonna give you the solution later. So the radius of conversion R will be equal to 1. Okay, in this case, it's gonna be when you have R equal to 1, the radius of convergence will be equal to 1, and this guy will be conversion when absolute value of x minus 1 smaller than 1. Okay, so this one will be just the radius of conversion. Okay, use the ratio test like we did earlier in this clip. Okay, so it's gonna be like in example 31. Okay, and it's gonna be that radius of conversion. Okay. The next one turned out to be the more important one. We like to find the Macrine series. The Macrine series means that you have A equal to 0, and you will have series n equal to 0 to infinity of the n derivative at 0 over n factorial, and you have x to the n. Okay, so this one is called Macrine Theory. So the thing that we need turned out to be the n derivative at x equal to 0 for sine and cosine. So you would have, okay, so you would have fx equal to sine x, okay, and you're gonna have another side gx equal to cosine x. Okay, so you have fx equal to sine x and gx equal to cosine x respectively. So in this case, you're going to begin differentiate. So you have f prime x equal to dip sine is cos, f double prime x will be dip cos is negative sine. Third derivative is going to be dip sine is again cos, so it's going to be negative cosine. And the fourth derivative turned out to be dip cos, right? So dip cos is going to be negative side, so it's going to be negative of negative side, and this guy become just sine x, so I'm going to write just sine x. Okay, and you have the fifth derivative. Dip side is cos again. Okay, and you have the sixth derivative. Okay, so you have the sixth derivative equal to negative sine x, and you have the seventh derivative. Okay, we need until 7. It's gonna turn out to be dip sine, so it's gonna be cos, so it's gonna be negative cos x. So in this case, this is what you gonna get. And you're gonna plug in x equal to 0 to see what's going on. Okay, so you need when x equal to 0, so you have f0. F0 turned out to be equal to 0. The first derivative at 0, so it's gonna be 1. F double prime 0 is gonna be 0. Okay, the third at 0 is going to be negative 1. The fourth derivative is going to be 0. The fifth derivative at 0 is going to be 1. The sixth derivative at 0 is going to be 0. And the seventh derivative at 0 is going to be negative 1. Continue. So you see that you're gonna have 1, 0, negative 1 alternately. Okay, so it's gonna be this guy. So you see that this one, okay, is gonna be for the odd guy. Okay, so for the odd guy, so when n equal to 1, n equal to 1, let me write in other color. Okay, so this one is going to be n equal to 1, n equal to 3, n equal to 5, n equal to 7. Okay, so this one will be 1, 3, 5, and 7, and the sign will turn out to be alternate. So the thing that we gonna have is gonna be, so you get n equal to 1, n equal to 3. What is 3? 3 is going to be 2 times 1. Okay, so it's going to be 2 times 1 plus 1. 5 is going to be 2 times 2 plus 1. 7 is going to be 2 times 3 plus 1. And this guy will be 2 times 0 plus 1. Okay, so you have n equal to 1, n equal to 3, n equal to 5, n equal to 7, respectively, like this. And you see that this one is turned out to be 1, this one turned out to be negative 1. So if you have n equal to 2k plus 1, the thing that shall determine negative or positive is going to be your k. So you see this one is 0, 1, 2, 3, and so on. So if you have f2k plus 1 at 0, okay, so if you like to have f2k plus 1 at 0, it turned out to be negative 1 to the k. Okay, it's turned out to be negative 1 to the k. You can see 0, 1, 2, k. So it's going to be negative 1 to the 0, negative 1 to the first. Okay, and this one is negative 1 square. Okay, give you the corresponding number. So you have the f2k plus 1 turn out to be equal to 0, and you're gonna have for even term f2k of 0, okay, at 0 turn out to be equal to 0. That take care the even term. Okay, so that taking care the even term, they all disappear. Okay, so they all disappear, and you have the term that odd power turn out to be alternate, 1 negative 1, 1 negative 1. Okay, so in this case you have psi x. Okay, so you have psi x must be series k equal to 0 to infinity, okay, of the k derivative. So it's going to be negative 1 to the k. Let me write it this way. So it's going to be sum k equal to 0 to infinity of 2k. Okay, so for the even part, at 0 over 2k factorial, and you have x to the 2k plus sum k equal to 0 to infinity of f to the 2k plus 1 at 0 over 2k plus 1 factorial x to the 2k plus 1. So you see here that this one is the red term, and it's turned out to be equal to 0, so it's disappear, and you have this blue term turn out to be negative 1 to the k. Okay, so this guy turned out to be negative 1 to the k, and it's gonna turn out to be just the term that you have. Okay, so I'm gonna just write the final answer. So this guy turned out to be equal to 0, so they are gone. So it's gonna be k equal to 0 to infinity of negative 1 to the k over 2k plus 1 factorial, and you have x to the 2k plus 1. Okay, so this one will be just the blue guy. Okay, so this one is for fx. Okay, so this one is for fx equal to psi x, and this gonna give you the Macrine theory, okay, for psi x. Okay, and the radius of convergence for this guy turn out to be the same as exponential. X can be any real number. Okay, so when you use the ratio test or anything, you can see quite clear that the radius of convergence will be infinity. Okay, so this one is how we deal with fx equal to psi x. Similarly, for cosine x, so let me just erase this one. Okay, so I like to erase the whole thing here. So you get dx equal to cos x. Okay, so you have dx equal to cos x. So you're gonna begin differentiate. Okay, so you're gonna begin differentiating this guy. So you have g prime x. Okay, dip cos, you get negative psi x. G double prime x is gonna be dip psi is gonna be cos. Okay, and g triple prime x is gonna be again what is gonna be negative. Dip cos is gonna be negative psi x. Okay, so it's gonna become psi x. Okay, so let me write down psi x. And we can just continue doing this one. Okay, so you gonna just you have the fourth derivative the fifth derivative, the sixth derivative, and the seventh derivative. Okay, and you have this, the same thing. I would just copy them, copy, and I should paste here. Hopefully it's gonna match. No, it's not. Let's reduce this guy a little bit. Okay, look nice. So you have the same term, okay? Dip side, you get cos, same thing. So you see that it will repeat it with the period equal to 4. So it's gonna be like this, and you gonna just plug in x equal to 0. So you have g0, g prime 0, g double prime 0, g triple prime 0, the fourth derivative at 0, the fifth derivative at 0, the sixth derivative at 0, and the seventh derivative at 0. And you see that it's going to be 1, 0, negative 1, 0, 1, 0, negative 1, and 0. And you see that you're going to have the term equal to 0 for the odd power. Okay, so for the odd power turn out to be 0. And for the even power, you see this guy is going to be 1, negative 1, 1, negative 1. So this one will be determined by the same thing. So you would just see that it's going to be n equal to 2 times 0, n equal to 2 times 1, n equal to 2 times 2, and n equal to 2 times 3. So for this one, okay, so for this one, it's gonna be, you see that this one is gonna be negative 1 to the 0, negative 1 to the first, negative 1 square, and negative 1 to the third, respectively. So the thing that determine 1 or minus 1 come from this 0, 1, 2, 3, okay? And you're gonna have g, okay? So you have g of the odd term, okay? 2k plus 1 at 0 turn out to give you 0. And you have g of 2k at 0 is turned out to be negative 1 raised to the k power. Okay, so it's going to be kind of same idea. So you have for cosine x, this guy will be sum k equal to 0 to infinity. Again, g2k at 0 over 2k factorial x to the k, x to the 2k, okay, take care the even term, and you have the series k equal to 0 to infinity, g to the 2k plus 1 at 0, x to the 2k plus 1 over 2k plus 1 factorial, okay? And you have the pink one, okay? So you have the pink one will be equal to 0, okay? So you have the pink one will be equal to 0. And you have the, let's highlight the pink one first before I move on. And I have the yellow one, okay? So you have the yellow one turn out to be negative 1 to the k. So it's gonna be just series k equal to 0 to infinity of negative 1 to the k over 2k factorial, okay, and you have x to the 2k. Okay, so that's it actually. So you have x is real number. So for this one, you have the power series for sine and cosine respectively in this form. And you're gonna have other formula. Okay, so we conclude everything for you. So you have e to the x equal to x to the n over n factorial from n equal to 0 to infinity. You have sine x turn out to take care of the odd term, and you have cosine x turn out to be taking care of the even term. Okay, so you have this one. And we also have arctan x already, so it's going to be series n equal to 0 to infinity of negative 1 to the n x to the 2n plus 1 over to n plus 1 from the previous lecture. And you have log 1 plus x given by this guy from the previous lecture as well. Okay, so this one will be collection of the thing that we have been studying so far. Okay, so it's going to be the representative of the power series for this guy. Okay, so let's try to find the power series for something like this. So you see that you have the power series for cos x. Okay, so you have cos x given by n equal to 0 to infinity of negative 1 to the n over 2n factorial x to the 2n. Okay, so it's gonna be like this. So you're gonna just change x to 2x. Okay, so you see this one is 2x. So you're gonna just change x to 2x. So you have cos 2x, so it's going to be series n equal to 0 to infinity, negative 1 to the n over 2n factorial, and you have 2x to the 2n. Okay, and so this one will be written as series n equal to 0 to infinity of negative 1 to the n over 2n factorial, and you see that it can be written in terms of 2 to the 2n, so it's going to be 2 to the 2n times x to the 2n. Okay, so this one can be written in this form, or more precisely, 2 square turn out to be equal to 4. Okay, so it can be written in this form also. Okay, so 2x to the n. Okay. Another one is going to be just x squared sine x. Okay, x squared sine x is going to be just, you have x squared, and what is sine x? Sine x is going to be n equal to 0 to infinity of negative 1 to the n over 2n plus 1 factorial x to the 2n plus 1. So you basically multiply everything for me. So it's going to be negative 1 to the n over 2n plus 1 factorial, and you have x to the 2n plus 3. Okay, so that is going to be this example 35. Let me give you more example for number 3. How about if I ask you what is sine x times cos x? Okay, so you have sine x times cos x, and you're gonna think that, hey, can we just multiply these two guys? Okay, you can actually if you multiply these two guys. However, it's going to be very messy. Okay, so it's going to be, you need to multiply this guy to this guy, and it's going to be very messy for finding the term. Okay, so it's going to be like you need to multiply this here, multiply this there. It's going to be too messy to find the power series. So we're going to use trig identity instead. So you see that the way to find this one is going to be 2 over 2. Okay, so you just write it's in this form, and you see that what is 2 sine cos? Okay, so you see that it's going to be 2 sine cos. 2 sine cos in this world that we had last semester is going to be, okay, so it's 2 sine cosine. So 2 sine cos is going to be sine 2x. Okay, so it's going to be sine 2x over 2. Okay, so it's going to be sine 2x. And so it would be 1/2 series n equal to 0 to infinity. And sine 2x is going to be negative 1 to the 2k plus, negative 1 to the k over 2k plus 1 factorial. Okay, and you have 2x to the 2n plus 1. Okay, so that is going to be the power series that you're looking for. Okay, so you may simplify this one a little bit to be series from 0 to infinity. Okay, and you have negative 1 to the k over 2k plus 1 factorial, and it's gonna be 2 to the 2n x to the 2n plus 1. Okay, so this one will be the Macrine theory that you like to find. Okay, I let you do this example 36 on your own. Okay, so you have fx equal to cos x to the third and fx equal to x squared e to the negative x. Try to find them on your own. Okay. The next one, we like to use this box to find the following sum. Okay, so if you want to find the sum, something like this, okay, it's not look nice, right? So it's gonna be something very strange. However, you see the term pi to the 2n plus 1 and 4 to the 2n plus 1. So for this guy, it can be written as negative 1 to the n over 2n plus 1 factorial. And you have pi over 4 to the 2n plus 1. Okay, and you compare with the thing that you have known in this box. So you look for, hey, it looks like something that we have learned. So you see that it's going to be even, odd, and it's going to be odd. And you see that it means that you are plugging in pi over 4 into the formula of psi x. Okay, so you have to compare this guy together with the one up there. Okay, this guy. So you see that it's gonna turn out to be basically just psi pi over 4. So this lesson turned out to be you need to recognize the term, and it's gonna be just this number in order for finding this sum. Okay, don't worry, you will have this box during your exam. Okay, so you will have this box for your exam, so it will be given, and you just use this box and you just plug in. Okay, however, you may have to do some algebra from this guy to this guy, and it's not going to be kind of difficult to do. Okay, so it's not going to be difficult to do. The next one is going to be you like to evaluate this guy as infinite series. The thing that you're going to do is going to be just you recognize this psi x squared. Okay, so you just have psi x, so you just have to just integrate, and you have series of psi x squared, so it's going to be negative 1 to the n over 2n plus 1 factorial, x to the 2n plus 1 from n equal to 0 to infinity of dx. Okay, so it's going to be this one. However, it's not x, it's going to be x squared. It is x squared. Okay, so this must be x squared. Okay, so it's going to be x squared. So it's going to be x squared like this, and you see that this will allow you to just have series n equal to 0 to infinity, and you basically integrate just x square and you have 2n plus 1 dx. Okay, I will let you complete this one on your own to see what's going on. Okay, I will do this during the recitation. Let's move on. Okay. Similarly, for this one, we like to estimate this integral from 0 to 1 of 1 minus cos x over x squared accurate to 5-digit decimal. Okay, so for this one, the first thing that we're gonna do is gonna be we're gonna change the cosine x. Okay, so we're gonna try to change cos x in terms of power series. Okay, so we're gonna change this guy in terms of power series. So it's gonna be series n equal to 0 to infinity of -1 to the n over 2n factorial. Okay, and it's gonna be x to the 2n. Okay, you may notice that I can write this one on my own without any help at all. And I have to say that I memorize this thing. Okay, so I know this one by my heart. So basically this one is going to be cos x and this one is going to be sine x, and I'm going to be able to write this one fast. Okay, so that you should be able to do. However, if you not memorize this one yet, try to. Okay. So for this one, it's going to be this one. And the thing that you're going to do is going to be, you would like to expand this one out. Okay, so when you plug in n equal to 0, n equal to 1, n equal to 2, n equal to 3, and so on. So you plug in n equal to 0, n equal to 1, n equal to 2. N equal to 0, you would just get 1. Okay, when n equal to 0, and you have x squared over 2 fact, and you have x to the 4th over 4 fact, x to the 6th over 6 factorial. Okay, so this one for n equal to 0, n equal to 1, n equal to 2, n equal to 3, and so on. Okay, so you're gonna just write this as, okay, equal to integral from 0 to 1, and you have 1, you have, sorry, it's going to be this 1 and minus, so you would just copy them down, so it's 1 minus x squared over 2 plus x to the 4th over 24, okay, and you have x to the 6 over 720 with the minus sign, and you continue, okay, negative like this, and you're gonna just have everything over x squared dx. Okay, this would give you integrates from 0 to 1. Okay, and you see that when you put this one, this guy and this guy will cancel each other, and the side will be opposite. So it's going to be x squared over 2 minus x to the 4th over 24 minus x to the 6th over 70 720. And the next term should be 8 to the 8 over 8 factorial, x to the 10 over 10 factorial, and you can continue, okay, like this, dx. And you also have everything over x squared. Okay, so you have everything over x squared. So this would be, okay, so this would be integrate from 0 to 1, and you have 1/2 minus x to the x squared over 24, x to the 4th over 720, x to the 6 over 8 factorial, x to the 8 over 10 factorial, and so on. Okay, and you'll be able to just integrate this one term by term, basically. So you integrate 1/2, so you get x over 2. You integrate x squared, so it's gonna be x to the 3rd over 24 times 3. You integrate x to the 4th, it's gonna be x to the 5th over 720. X to the 6 is going to be 7, and you have 8 fact times 7, and you have x to the 9 over 10 factorial times 9, and so on. Okay, and you have from x equal to 0 to x equal to 1, and you would just plug in. Okay, so it's going to be 1/2, okay, when x equal to 1, and when you plug in x equal to 0, they all disappear, so no need to worry. So you're going to get 1 over 24 times 3, okay, plus 1 over 720 minus 1 over 8 factorial times 7, and you have x to the 9 over 10 factorial times 9, and so on, so forth. Okay, so when we reach this one, okay, I have to turn on my note right now because it's gonna involving many terms. So you see that, okay, I gonna have okay. So you see that this is a calculation that we have so far. And so you're gonna just plug in numbers. Okay, so the first guy is 0.5 for sure. Okay, the second guy will be 0.1388, 0.1388. You can use calculator, not you not be able to do this one on the calculator, or if you be able to on your calculator, this is the process that you use to estimate for this one. Okay, so the calculator working by the thing that we are doing right now. Okay, the algorithm that the computer have turned out to be just the Taylor polynomial or Taylor series that we are doing right now. And it's gonna be the next one, it's gonna be 0.00027, okay, and you have minus 0.1, 2, 3, 4, 5, 3, 4, 5, 3, 5. Okay, so you see, okay, let me highlight. This one is 0.5. Okay, the second one is okay. The third one is here. Okay, and the fourth one is here. Okay, and the fifth one, okay, so I don't quite care much. So this one will be not x to the 8, right? Sorry, it's going to be 1. It's going to be 1. So for this one, you can just see that, okay, you like to have it 5-digit accurate. Okay, so if you want to have 5-digit accurate, you can stop, because if you continue, this one is going to be 0.00000 more than 5-digit. Okay, so it's turned out to be more than 5-digit. So for this one, you can just see that if you like to have 5-digit accurate, so this one is already 5-digit. Okay, so this one is already 5-digit. Okay, so we can stop here and you just sum these 3 guys up. Okay, so this one will give you accurate 5-digit places, 5-digit places, right? So 5 decimal places, 5 decimal places. Okay, so in order to have it accurate, accurate 5-digit, 5 decimal places, right? 5 decimal places is going to be this number, and the number that you calculate here is going to be just sum these 3 numbers up. Okay, and it's going to be 0.48639. Okay, so it's going to be this one. Okay, so you see that we can just use the power series and you'll be able to give an approximation for the definite integral that you not be able to integrate. Okay, so for this function, you see that you not be able to integrate and you need the good way to estimate for value. Okay, the last one, okay, the last one is going to be, we like to use Macrine Theory in order to find this one without using L'Hopital. Okay, you can try to use L'Hopital. Actually, it can be done in that way also. However, for this L'Hopital, you're gonna see that it's gonna be kind of messy when you differentiate. The thing that I suggest you to do is gonna be, you're gonna use the power series for sine and cosine. Okay, so you're gonna use the power series for sine, for arctan, for log together. So you just plug in terms of power series for sine x, for arctan x, for log 1 plus x. Okay, I will let you try on your own first. And then after you find this one, simplify and take x go to 0. You're going to see that it's going to turn out to be nice constant. Okay, and I give you the solution for this one. Okay, so you are aiming for 1/6. Okay, so try to change sine into power series, arctan into power series, and log 1 plus x into power series, and then you gonna just simplify and you take x equal to 0, so everything will disappear except constant, and it's gonna give you 1/6. Okay, so try this one on your own. I give you the solution during the recitation. Okay, so that's all, and that's gonna be it for this long lecture. Okay,